Monday morning, 10 a.m., first talk of DappCon 2023 in Berlin. And I'm personally happy that it's this early and on the first day because I get to party after at 11 o'clock this morning, which is good. So do you have your computers with you? And I just wanted to ask, would you like me to walk with you to try to install? I'm going to talk about TrueBlocks, which is the project I've been working on for about 6 years. The fundamental idea behind TrueBlocks is, why is the node software so hard to use, and what would we have to do to the node software to get it to be better so that it would be a better data server? So I'm going to start the talk by having you install TrueBlocks, if that's what you want to do. It's optional for you. You can follow along, and I'll jump right into that. Then I'm going to talk about running running the node software locally. How many of you have ever run node software locally? Any? All, but maybe, have you? Yeah. Did you run it on what kind of machine? What kind of machines were you running on? Mainnet Ethereum or what? Yeah, that's great. That's amazing. And did you guys run the server yourself? You've run many servers. Yeah. So I'm actually running a REST server here against Sepolia. So I'll show you what that looks like. And part of what I want to say is that running a server is nowhere near as hard as running a node software is nowhere near as hard as people think it is. So I'll just jump in and get started. If you all go to this page, we can kind of follow along. So do you all have build environments basically on your machines? Go language, do you all have Go on your machine? Who doesn't have Go on their machine? Why don't you visit the Go site? Maybe you can try to catch up. I won't wait for you to. Okay, great. And you all have Git, I imagine, and you all have CMake. Do you have CMake on your machines? Okay. So I'm just going to jump right in. I'm actually kind of amazed that you all run nodes. Can I ask, why do you run your own node?
I want to do blockchain indexing.
You want to do data analysis, or do you just want to do after indexing, then you want to get data?
Yeah, for data analysis for investment purposes.
Yeah, you want to look at addresses and see what they're doing, kind of.
Yeah, exactly.
Yeah.
So who buys what, when, and
Who buys what, when, and yeah.
do a kind of cluster wallets.
Nice. Have you tried TrueBlocks yet? Okay, great. And you guys, why do you run nodes yourselves?
For our reason is that we have one, and private to stake.
Do you run a node, you said?
No, but I work for a company. That provides nodes as a service.
Oh, okay, great. And indexing is something that you're interested in, or?
Yes.
Yeah, and I know these are all Rocky people. Oh, a little bit of a shill here. Rotkey, pick it up. It's a great piece of software. So I tell people that accessing the data from a locally running node is orders of magnitude, and that's 2 at least orders of magnitude, in my opinion, better than hitting a remote server. Nothing, present company accepted over here. And I say that running an Ethereum node locally is not as hard as people think. And even if you do run an Ethereum node locally, you'll find that the RPC doesn't provide probably what you want it to provide. It doesn't give you access to histories of accounts. So that's what TrueBlocks tries to do. So I'll go a little bit light. Is everything good? So there's a number of things for me that Web 2-like APIs and Web 2-like access to data doesn't agree with the Web 3 ethos. For example, rate limiting, and we're going to see an example of that in the demonstration. They kind of have to know who you are so that they can rate limit you. If they don't know who you are, they won't be able to rate limit you. So all of those things kind of make me want to see if we can't do it a different way. So let's get started with installing TrueBlocks. So I'm going to skip down here. And if I'm just going to go and do these commands, and you're more than welcome to try to do them yourself, unless you already have it installed. So this is downloading and installing TrueBlocks on my machine from Git. And then I'm going to CD into that folder, make a build directory, and change into that folder. Type cmake, and then type make. So I'll just show this again. If you want to go through these steps, and when you get to the place where you can say that the ls-l shows you Shifra, then I'll continue. Just go on. Are you following along? Yeah. Are you all at the place where you have Shifra installed or built? That was amazingly quick. Type Shifra and hit enter. Can you? And you get a screen just showing you a bunch of stuff. Is that true of everyone? Should I wait or should I proceed? I guess I'll just proceed, and then if you want me to stop, you can just ask me to slow down or back up a little bit. I've already shielded your, I held this up to the whole world, so. So once you have it installed, you have to, it's going to make the rest easier if you put this thing in your path from the build folder. And then you can run Shifra version and Shifra status. And just give me a thumbs up if you have it running. I got 0 thumbs up, so nobody's running it. So 1. Okay, good. We got 2. As soon as we get 3, we're going to move forward. 3. Should I wait a minute, you guys? You're from Gnosis, you guys? Oregon?
Yeah.
Oh, sorry.
I'm sure we need to set up my video.
I should have.
Show my hand.
That's all right. So we're actually working on a Docker version, so it would just become a one-line command. But so I said that I was running my own local node. So I just wanted to spend a minute and show you that. So what I did to run my own local node on this laptop, which has a 4 terabyte hard drive, this laptop, is I just went to Reth's GitHub repo, and I downloaded the GitHub repo for Reth, and then I typed a single command. I just typed docker compose up, and Reth starts. And it opens 5 pieces of software. So this is Reth starting. And it opens 5 pieces of software. One is the consensus layer. That's here, I believe. Yeah, this is Lighthouse. That's the consensus layer. It runs 3 pieces of monitoring software, and it runs the execution layer of Reth. And this, I think, is really nice because I can open up a panel that shows me that Reth is syncing. And this makes, I don't know if you've ever tried to run a node, trying to figure out if it's actually syncing is really a pain in the ass. So this is really beautiful. I just leave this open, It constantly updates, and when it's synchronized, now I can start using this node. So this is synced against Sepolia, so you can see it's blocked 4,200,000. Is everything okay? And this was as easy as it could be. It took a one-line command, it's up and running, it's in Docker. As soon as Docker starts, Reth starts, and it's constantly running, constantly updating, and I don't have to do anything. So Vitalik once called the node a big, hairy node, and I'm like, it's not that hairy and it's not that big, so you should try to run it. But So I just wanted to show you that, and I'm ready to move on. Is everybody ready to move on? Should I move to the next step? Well, that's the least responsive audience I've ever seen in my life.
Yes, we're ready. I'm good. Ready.
Okay, thank you. I'm going to move on. Thank you. So, so type Shifra status on your command line. And it's going to show you, I just wanted to point out, it shows you what node you're running against. It shows you what release of TrueBlocks you're running against. It shows you what chain you're running against. It shows you a bunch of folders that are useful for configuration. And it shows you some numbers here. So these numbers are, this is the head of the chain. That's the head of the Gnosis chain. And for this installation, this is our index. This is how far along our index is, which is not far along at all because we just started. We didn't do anything to get the index. So we're going to try to get the index. You can try to type this command in your browser, in your command line. And I'll type the same command. So after it downloads a file, it's downloading a timestamp database that we publish because timestamps are a real pain in the node. One of the real shortcomings of the node is that it doesn't really give you an easy way to get timestamps, get block data from a timestamp. So this is saying that TrueBlocks is not properly initialized. Is everybody there? Do you see that message? Again, moving forward without any response. The next thing you can do is, it's telling you that you need to scrape the chain for the index. So I'm just going to spend a minute telling you what we mean by that. So let me go here. Oh, shit. Sorry. I'll be with you in a minute, sorry. So I just wanted to take a minute to tell you about our index and how we build it. So I said earlier that Shifra has a whole bunch of different commands. Some of them are related to building and managing the index. Some of them are related to, once you have the index, getting access to the data about particular addresses. And a lot of them are related to just getting plain blockchain data. So what we did is we took the RPC and we kind of said, where is it inadequate? And it's inadequate in a lot of places, but we added features to the RPC, basically, that allow us to do certain things. And one of the things that we added was a command called unique. So we have a Shifra blocks. It's exactly the same as the RPC endpoint for ETH_get block. And we added a unique tag, which allows us to look at every single bit of the data in any given block and pull out every unique address that appears in that block. And this is the basis for our indexing. So we basically scan through the chain, one block at a time. We do it in parallel, we're in Go. So we do as many blocks as we can at a time. And we're just pulling off addresses that we find and recording which block and which transaction they're in. We don't pull any other data at this time because we don't want to create a giant database that's a full extraction of the data from the chain. We want to create the absolute minimal index so that it stays on a small machine like a laptop. And that's in the unique feature. And what this does, basically there's two different kinds of places where the data could be. It's going to be in things that are very clearly addresses in the block. One is, all of these are pink, all these pink things are things that are, they're defined in the data as addresses, so we know that they're addresses, so we pick them off. There's a whole bunch of other places where there's just long strings of byte data in the block data, the trace data. And we do something a little crazy, kind of crazy, I guess, because I don't think anyone else does this. What we do is we take advantage of the fact that solidity, did I lose my connection? We take advantage of the fact that solidity packs addresses with leading zeros in byte data. And we can get these strings of thousands of bytes, and they might have hundreds or thousands of addresses in them. And we scan every single bit of all of that byte data, and we're going 32 byte chunks at a time, and we're saying there's a bunch of leading zeros there. And what we do, we know that this is potentially not an address. It doesn't have to be an address. Every 32 byte string is actually a valid address. Well, no, it has to have leading zeros. So we can chop off anything that doesn't have leading zeros. This one, for example. And if it has enough leading zeros, we say it appears to be an address. We don't say it is an address, we say it appears to be an address. That's why we call them appearances. And what we get, but then for some things we say, this does not appear to be an address, so we don't accept that as an address. And we throw out anything which has too many leading zeros, and we keep anything that has just enough leading zeros. And what we get is an index that is richer, and by that I mean it contains more than other indexers find. And I think that's because they don't even look in that data because they just think it's unintelligible byte data. But we're kind of, it's not a perfect solution because there literally cannot be a perfect solution because any 32 byte string is a valid address. Even 0001 is a valid address. So there is no perfect solution, but we want a solution that's as good as it can be so we can get as many appearances as we can. And we looked at Etherscan. They provide 7 endpoints for getting various different types of lists of histories. And we compare ourselves to that. After taking duplicates out of their entries, we get on average about 13% more appearances than they tell us happened to an address. And I think this is not only Etherscan, I think it's a lot of indexers are not looking deep enough into this byte data, so they come up short on their index. And when we look at where exactly it was that we found things that they didn't find, it's always in the byte data. So we're definitely finding some stuff that other people aren't finding. And then when we look at what exactly was that byte data, it's things like this. It's monetary things. Purchase, mint, trade with hint, split, donate. Those things are being missed by the major indexers because I don't think they're digging deep enough into the byte data. It's as simple as that. So we want to create the best possible index, recognizing that you can't create a perfect index because of that byte data problem. And then we want to build the index, and we do something a little bit different here as well. So this is block unique, and we're getting random distribution of addresses because they just appear as in a transaction as they come. It's time ordered. And an index, of course, wants to be sorted. But as soon as you sort this index, you lose what I call immutability or reproducibility or a proof or something like that, where if we were to take this data and put it into IPFS, it would stay the same forever. If we were to take this data and put it into IPFS, it stays the same until we add a new record, and then it changes on IPFS. So for us, that didn't work because we didn't want to build something that lost that reproducibility. So we came up with a pretty simple solution, actually. We just stop adding records after a certain amount of time. And we do this pretty much exactly for the same reason that blockchains stop adding transactions to blocks, because they want to create a fixed place in the world, a fixed bit of bytes. So we take the list of addresses, we sort them, and then we chunk them into chunks of index pieces. And we call that whole process scrape. So I'm going to go back to my command line and type Shifra scrape, because we don't have the index locally, and I want to build it. And it's telling me, hey, it's really great that you want to scrape, congratulations. You can't do that because your remote RPC provider doesn't provide traces. And I'm saying we need traces if we want to get a full index. Now, we could turn this warning off and let people build an index if they wanted to without traces. And now you're going to get logged, basically you're going to get logs or from and to addresses in the transactions. But that's 60%, I don't know the number, it's 20% less than the total. So you're going to miss all these important transactions that are actually transferring value. So there's an alternative. So we bump into this problem. And basically, Web 2 providers, they give you access to their sorted index, which puts them in a position of power towards the end user, which is something I wanted to avoid. So you get this end user is totally dependent on this web API provider to continue to give them data. They're also dependent on them to make sure they get valid data, true data. So I wanted to avoid that situation. Our first iteration, we didn't avoid that situation at all. We just gave people web access to our chunked index, but that didn't feel right. So then we kind of set the user aside for a second, and we said, let's publish this data out. Because it's immutable, let's publish it out to IPFS and keep track of all the hashes that we've created for each chunk, and then put that in what we call a manifest. A manifest is a list of every one of the chunks. And then we publish the manifest to a smart contract that we call Unchained index. And now what I've done, or what we've done, is we've created an index that is represented by a single 32-byte hash that any person on the planet Earth that has access to smart contract, which is every person on Earth, can bring down to his own computer, her own computer, and they have a list of every piece of the entire index. And I can't take it back after I publish it, and that's on purpose, because I want to eliminate my ability to become the controller of the situation. I'm giving away the control on purpose, because I want to, I'll show you why I do that. Now the user can say, Shifra init, and then he can use some other tools from Shifra and build his application. Now the trouble with that, it's about 100 gigabytes big. So I'm going to come back over here and type Shifra init. You can do this if you want. It should work on your computer if you want. It doesn't bring 100 gigabytes down. It's going to bring only 3 gigabytes down. So how many of you have heard of a Bloom filter? So Bloom filters are astonishing. They take megabytes of data, and it's a list of addresses, and it creates from a megabyte or 50 megabytes of data, it creates 50K bloom filter. And because it's immutable, I can put a bloom filter in front of every chunk of my index. I put that bloom filter into the manifest as well, so when users download the manifest, are you with me? Sorry. Are you with me? Great, thanks. I just didn't know. Who's with me? How's it sound? Sound like it might work? Sound like it kind of works? So creating these small bloom filters that I can publish to a smart contract. Everyone can read that smart contract, pull down the list of bloom filters, bring them local to their own machine. And now they have exact understanding of where in the history of a chain their address that they're interested in appears. So let me show you what that looks like. So did anybody here run Shifra init? And is it running? It's gone through? How many, yeah. Yeah, you can type Shifra, config edit, and there's a section there for mainnet, and you can add your RPC endpoint there. You also have to change the default chain in that file to mainnet. I'll show you what that looks like as soon as this finishes here.
Then the Bloom app is like compression on top of chunk of addresses.
It's so interesting what it is. It's like, it's a bit string, so it's ones and zeros, and I can take any address and I can hash the address, and then I pick five bits out of that hashed address, and I light them in the bloom filter. So if I put 2 addresses in, it might light 8 bits. If I put 10, it might light 30 bits or something. So when I query the bloom filter, if I hash the address again and I look at the same 5 bits, and if it says yes on all 5 bits, then I know that it's in that chunk.
So it's like
You should read about bloom filters.
it's like a hashing.
It's super compressed. Basically what it says to you is the address that you're asking about or the data that you're asking about may be in the larger piece. It can say it's absolutely not in the larger piece because one of the 5 bits is not lit. But if it says 5 bits are lit, it's not saying it is, it's saying it may be. And it's really a magnificent thing. You should read about it. So now I'm finished, and now I have all of these blooms, and I have 3 gigabytes of data on my hard drive, and I have a bloom for every one of the chunks. And now I can query against the bloom filters. And I'm going to do that here. I'm going to say Shifra list TrueBlocks.eth. And this is saying I hit on these 7 bloom filters out of the 1,000 that I have. I hit on only 7 because TrueBlocks.eth only interacted with Sepolia in those locations in the chain. And it then downloaded just those 7 chunks. So out of 2,000 chunks, or 2,000 full chunks, in order to get a full history of TrueBlocks.eth on Sepolia, I download 7 chunks. And now I have 7 chunks on my machine. I have all the blooms and 7 chunks. And what I would love to see happen is, and now if any of you have any of you done Shifra init and then Shifra list? Have you? Yeah. So when you did it with your address, and you got a totally different set of chunks because you have a different history. And this is done on purpose because I want each user to be pulling their own weight, They bring their own list to their own machine. There's false positive rate, which means that they get a little bit more than they really need for their own use case, which makes them a contributor to the system instead of a drain on the system. They're carrying part of the data. And we can turn on a switch that makes it pin by default. So once they have the chunks down on their machine, we can have them pin this data down on their machine. So what happens now is everyone is sharing in the burden of the data. And we don't have a situation where one entity has the index. And I wanted to build that on purpose because I wanted to explore what it would be like. And it actually works. I think it works if I get adoption and I can get people to use it. And it has all these amazing qualities. So I'll talk about two. One is unlike a Web 2 API, where if let's say I get 10,000 brand new users in one day, I literally have to go out and buy new machines because I have more and more and more people hitting against my central place. And that's why you need rate limiting. You have to keep people from hitting on it too hard. But if I get 10,000 new users here, we have 10,000 more copies of these pieces of the index out there. So the more and more and more people that use this system, the system itself becomes more resilient naturally without anybody having to do anything, and that's really important. The other thing that's very important and interesting is I have 10 chunks because I'm just a little guy doing little things. Uniswap is in every single block on the mainnet blockchain, and if they use this, they would download and pin the entire thing, which means that a heavy user of the chain carries a heavy burden of the data, and they should exactly do that. They shouldn't impose their use case on us without giving back to the community by sharing this index out there. So those two things are very important to me. They're not really something that TrueBlocks does. It's just something that IPFS does. This is just how IPFS works. Yeah.
Well, what is the concept of apps? Because it says app and...
Oh, I shouldn't use the word apps. It should say appearances. I found those many appearances in that line.
Yeah, when I did the list command, it said happening for apps.
Yeah, apps, I should use the word appearances. What it's saying is in this chunk, I found 23 appearances or something. So is everybody with me kind of on this thing? This is kind of the thing I wanted to really get forward is we don't have to rely on web APIs to give us this data. We can build, all of this could actually be built into the node software so that it did this automatically. We can pin it on any content addressable storage we want. We can publish to some smart contract, and everyone can benefit from and help deliver this data to each other. So now I have on Sepolia TrueBlocks.eth transacted in these locations, and I know exactly what locations they are, and I can do something like this. I can cut off the block. I can get rid of the header. And now I have a list of just blocks. I'm going to store that in a file called blocks. And then I can do a command like this where I say state. I want to do state for TrueBlocks. I want to get basically the balance for TrueBlocks on Sepolia at every one of those blocks. Now, I don't have any money on Sepolia, so it's all coming up with zero balances. So I'm going to switch. Let me just do this. I'm just going to turn this off for 1 second. So I'm going to say, I want to see TrueBlocks on mainnet. You'll allow me to log into a different computer to do this, but so on mainnet, TrueBlocks has 4,000 transactions. So this is showing me the balances at every one of the blocks where I appear in the chain's history. And this is the basis for the next thing that I want to talk about, which is what I call reconciliation. So you'll notice there it went up to 76 for a minute. We got some funding from the Ethereum Foundation, so that was very, very helpful. But if you have, and remember I said that we have 13% more transactions, we find that, and a lot of those transactions are financial in nature. And the reason I'm interested in getting those transactions is because I want to know at every block where that address transacted, what was its balance, either in Ether or in any token. So I can actually also say, I can say Shifra, names, DAI, stablecoin. I know it starts with OX6. And that's the DAI stablecoin. So I'm going to take that. By the way, you guys are supposed to be following along with me, but I kind of lost you, so I'll just continue on. So I'm going to say, I want to see the token balance for DAI, for TrueBlocks, on all of those blocks that it transacted in. Token balances, don't know anything about Ether balances, so I'll take that off. So this is my holdings in DAI, or any token that I want to look at for every place where this thing transacted. And now my goal is to say, how do I know that the balance at the previous block was the same as the balance at the beginning of the next transaction? Because that would be reconciliation to me. So I can say, I know it was $10 here. 2 months later, it was also $10, and now I know that I didn't miss a transaction in between. And then within each transaction, I want to say, beginning balance was 10, I spent 3, gas was 1, so I better have, whatever that is, 6. So that act of reconciliation, to me, is a demonstration that I have a complete list of the history, and I haven't missed something. And then you can actually extend that. It's not just balances of tokens. It's not just balances of Ether. It's actually state changes in a smart contract. So I can say, I know that the number of votes was 200. I know that in the week of June 1st, 3,000 new votes came in. I better have 3,300 votes or something. And you can reconcile state. And to me, that's the whole point of a blockchain that has literally perfect state management for 300 million accounts, 100 million smart contracts, however many. On-chain, it happens every 12 seconds. Off-chain, nobody knows what the hell's going on any of these smart contracts. They kind of have a feeling that they do, but they don't know in depth because they can't reconcile what's happening off-chain. And to me, once we get to the point where we're reconciling state changes off-chain, I think then we get adoption, in my opinion. Because if I'm a business person and some guy comes along and says, hey, you know what? We're pretty good with the accounting. We're about $10 off here. I'm going to say, no, we're not. We're not going to a smart contract. You have 18 decimal places on chain. Give me 18 decimal place accuracy. And when we do that, I think we'll get adoption because it's a better accounting system. So off the soapbox, I have all the time in the world. I have 20 minutes left, so all the questions, yeah?
The reconciliation is based on transfer events, so you look for
No.
or balance at the beginning.
I don't look at any particular thing. I look to see if the address is present in the transaction. And if it is, then I know that I have to reconcile something in that transaction. It can be a transfer. A lot of times it's not a transfer, which is why regular Web 2-based accounting people are coming up short on their ability to reconcile your endpoint, because They're looking only at events. If you look only at events, you're going to miss things, and it's not going to reconcile. And kind of the reason why I know this is because I started from reconciliation. I wanted to reconcile first, and every time it didn't reconcile, I went and looked for the place where something changed. And it was always in this byte data. And it was frequently not in event data. So you can't really reconcile with just events, even though that's kind of the theoretical way that it's supposed to work. It doesn't work that way. That's why I kind of say that you have to have tracing, that you have to dig as deep as you can, and if you miss something, it's just not going to reconcile.
So, because the REPT Ether contract is notorious for that, right?
It is.
Have that event emitted or
Yeah.
withdrawal.
Yeah.
Are you saying that out of the box, this is already seen and reconciled?
Well, we're definitely going to find that appearance, right? Because we're not only looking at events, we're looking at just appearances. We know that it's in there, in that transaction, something happened. We don't yet know what. But I know that we can look through, we now have, we're at that transaction, and we've been keeping track of balances for 50 tokens in the history of this this address. And we can say, let's look through the data and see if there's any tokens in there. And we have some heuristics on how to find the tokens. If they respond with a name, then we think it's a token, and we try to balance it. We have every address that's in that transaction because we have that unique thing. So we say, we don't really know what happened. Do a unique, give me all the addresses that are in here. Any of them that are tokens, I'm going to try to reconcile them. I first do a balance against the previous time I saw that token, and then I do a balance against the current time, and if it changed, then I know I have to reconcile. And I reconcile by doing everything I can to reconcile, looking at events now, looking in some data. We try not to do particular things for particular addresses. So if I fail and I get to the end and I can't reconcile, now I make an entry called correcting entry. And it comes out in the, in the data that here's the thing that maybe the accountant wants to look more deeply at or something, because we can't figure it out in a generic way. I never wanted to make it specific for specific addresses because that's not sustainable for me. But we're thinking about how we can extend, allow you to extend and say, I know this address, do this thing to get the balance, right? So that's in the works. It's kind of not yet ready, but yeah.
So in this case for REPT Ether, you would have to add some custom logic.
I'd have to look at it. We might be lucky that it kind of comes out in one of, we probably have 10, I said that we didn't have any special cases, but we might have a couple of special case code where we know that it's weird like that. The more popular things we'll do. But we try to avoid that because it's not really sustainable.
But no matter what, it gets flagged at the end so that you know something.
Yeah, either we reconcile because it all makes sense and we find why it reconciles, or we say we can't reconcile, make an entry that sticks out as something weird is happening here. Any other questions?
Ask a related question to Discord. So that means, for example, I asked for Uniswap, for example, when I want to get all Uniswap trades, so who traded coin X and coin Y, there is, in this process, there's no need for custom logic for all contracts. Because there are so many different DEXs, for example.
Well, it's so interesting. It's an excellent, excellent question. Really, truly is a great question. Here's the thing. Every single one of them, every single one of those custom weird shit that's happening, every single one of them is trading tokens. ERC20 tokens, almost always ERC20 tokens. And we look at ERC20 tokens, and almost all the time, we can reconcile on the change in balance of an ERC20 token. It may or may not show up in an event, but we know that the token balance changed from beginning to end, and we can say there was a token transfer of some type here. If it's positive, that's a mint maybe. If it's negative, that's a burn. If it's a transfer, it probably showed up in the transfer event. So all those crazy things that you're talking about, I was kind of lucky when I discovered that it didn't really matter because we just look at tokens.
And this is in the ERC20, this is get balance, although this is
It is.
it calls get, this is kind of, you get the balance and then you lock the balance over the time.
It does.
You get the address.
It does, yeah. It turned out, I mean, I was worried about that problem, because everything's, slightly different and in just the tiniest little way. But it turns out that what they're doing down at the bottom, even a transaction that has hundreds of calls to hundreds of smart contracts, all of them at the very bottom are just transferring tokens. And we can kind of reconcile if we look just at tokens. It's not perfect, but if it doesn't work, then we give a special entry called, balancing entry or correcting entry or something like that. So, yeah, it all came from my desire to reconcile, right? So every time it didn't reconcile, then I went and spent 3 days trying to figure out where was that little mistake or where was that thing happening. So that's where it all came from. So anyway, people, they say, why so many files on my local computer? I don't like that. Or they say, how inconvenient, what a pain in the ass. And to that I say, yeah, well, tough. It's tough luck, It's like, if you want to be in a decentralized world, the first thing you have to do is decentralize the world. So that's just part of the game, is that you have files on your computer that you might not have had otherwise. Other people say, I love the command line, but I really love an API. So one of the commands that's available from Shifra is called serve. So there's a command here called serve. We call it daemon, but it's serve. And serve serves every one of these other endpoints with exactly the same options as the command line options. So you can stand up a server and write an application against this thing with really fast, really good, deep, accurate data for the history of accounts. Smart contract developers could use this. So, they probably use the graph today, or they use their own indexing tools or whatever. My guess is their own indexing tools are very specific to their own contract, so as soon as they go to another one, they have to rewrite that code. The graph only looks at events, as far as I know, unless it might look at traces at this point. Do you know? Just event.
By function calls, but it doesn't simulate, so you miss some parts.
Yeah. So, and very important to me, why do I have to pay for access to the data through buying coins? That just makes no sense whatsoever. We should just fix the node software so that it actually indexes, because that's what the community needs, and the community's constantly building it. And companies are coming along and saying, hey, I'll do the indexing for you, pay me $300 a month. It's great, fine. I can write software that literally changes the node software so the node does it automatically without having to pay anyone to do anything. And I think we should do that. So I'm not going to, I have 10 minutes left, so we can do anything you want. I have a couple other examples, but I'm happy to ask or answer. I could ask some questions as well. I would absolutely love for you guys to tell me, are you running TrueBlocks? Any of you? How's it, and it's working well for you?
Yeah.
What do you do with it? Like?
I started 2 weeks ago.
Oh, okay. So you haven't gotten through the 2-week period. At the end of 3, most people quit using it because it doesn't really work all that well. But
What does the API look like? Is it REST API, GraphQL, or how do you get the data out of it? And is it processed by front-end, or do you need the back-end to actually use that?
so in order to start the API, you type Shifra serve. So that started the API, and then I can just hit it with curl or something. Hold on. So that's getting data from curl after having started the server, and the API is identical it's identical in every way to the Shifra command line tools. It has exactly the same options, and you basically use it exactly the same. And we built this part because we want to build little applications. So maybe I want to build an application that looks at my Gitcoin grant behavior or something and compares it with Rocky, because I do that all the time, to my detriment. Any other questions? Yeah.
When are you going to have it in the node then?
Excuse me?
When are you going to have it in the node? In red, let's say.
I'm sorry, any other questions? I'm going to have it, I don't care if TrueBlocks is in the node. I don't care about that. I care that indexing is in the node. And I think that people will come to understand, especially as we go to 40 layer 2s, that if the only way for people to get accurate histories is through an API provider who's charging $250 for layer 2 number 1, layer 2 number 2, every one I want to use, people will understand eventually that this is a problem that can be solved in the node software. And it should be solved in node software. So I kind of don't, I've beat my head against the wall for 4 years. This should be in the node, this should be in the node. And I know it should be in the node. When is it in the node? When people understand that it needs to be in the node and demand that it gets put in the node. I'm not even gonna probably fight that battle, other than to stand up here and say it should be. Do you see what I'm saying? It's too hard. That's too hard a problem. I can't do that.
Because the node developers,
Node developers are what?
the node developers, the client developers, they're not interested?
They are busy enough, kind of. They have enough on their plate, and there are solutions out there that, take the burden off of them. People don't demand it from them. People accept that accounting software, which is using all these APIs and coming up short, they accept that it's okay for the accounting software not to reconcile. So I think in the end, we're going to figure out that indexing is going to be, and not only indexing, but indexing that actually works and produces reconcilable state off-chain and is fast, it's not costly. I think we're going to figure it out, and if we don't figure it out, we're just building something that I don't even give a shit about, to be perfectly honest. It's just not interesting. It's just the same old thing. And I can't, it's like, I can't solve that problem. I can just show people that it's solvable, right? Any other questions? We have like 5 minutes. Does anybody want to ask anything? Yeah? Oh, sorry.
Given a smart contract address, can you query which transaction it was deployed?
Yeah, absolutely. Because we see every appearance. So deployment, it comes in the receipts contract address thing, so we'll pick that off naturally.
Even if it's internal transaction?
Yeah, because we dig into each little piece of the bytes, and down in the traces, there's a trace response, I think, or reply or something, and it's in there. So.
Is it something that I can find in the API?
So tell me, well, I'll just pick a smart contract, like let's say the Gitcoin. So we've also been doing something that I probably shouldn't tell people, but I'm going to. Everybody goes on Twitter and says, give me your address and I'll give you some tokens. Every single time that people have done that for the last 7 years, I've copied all of those addresses along with their Twitter handles, and I put them in a database that's called names. So we list 13,000 names where you guys have doxed yourself. And I don't apologize for it. It's not my fault. I can say Gitcoin core. This one. So this was the Gitcoin address. This is a smart contract. I'm going to say Gitcoin list. And it's going to go and get, this is Sepolia. Let me go into mainnet, hold on. So I'm on a different machine now. So I can say Shifra list. This is Gitcoin on mainnet, okay? So that's every appearance. And the first appearance is where it was deployed, okay? Huh? Yeah, the block number and the transaction ID. Yeah, that's right. That's what an appearance is. It's an address and where it appeared, so we can find it. We don't have to scan the chain to figure out where it is. And then I can say export. I can say format JSON, and I can say last block, and take this block +1. And that's the deployment there. That's the deployment of Gitcoin. So it kind of just naturally falls out because we find we find as many appearances as we can. Yep. And this is really interesting for like Uniswap as well too, because we can see the factory creating smart contracts. Yeah. Anyone else have any questions? Any comment? Can you guys give me some feedback on TrueBlocks? Should I continue working on this project, or can you help me get some funding, guys? Who has funding? Who has funding? Raise your hand if you have funding. Hello? 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 All right, great. So I'll just continue this project on my own funding. That's a great idea, yeah. I'm going to just turn this into a business if you guys don't help me out. Retro, yeah. Vote for me if you're a voter on the optimism. Vote for my project, because I'm really all about sort of, we can do this as a community, because if we don't do it as a community, somebody's going to capture this thing. Somebody's going to take it away from us. They're going to have it. We're not going to have node software that even comes close to doing this in the future if we don't get it to do it now, because in the future, the big data providers are going to move the needle of where the node software behaves to the point where it can't even do what I'm talking about, because they throw away the ability to run node software on small machines, because it's not in there. They don't need that, so they just toss that. It's not a purposeful act. It's just what happens with software is it gets pressure from the place that people are pushing on it. And if we're building APIs, Web 2 APIs, and all the node software is behind a Web 2 API, all the API providers are deciding what happens with the node software. So I'm saying, let's not let that happen. Let's change that and make it happen a way that works for us. So thanks for coming. I really appreciate it. We have a question? Absolutely, yeah, certainly. Yeah. Now, what they did though is they went into the internals of Aragon. And I kind of chose not to do that because I wanted to stay so I could go against any node software. So, I don't know that their indexing is quite as thorough either. They're more focused on the indexing you would need for a blockchain explorer, which is maybe not the same thing as for reconciled state histories. But yeah, no, I'm friends with them actually. They're talking later today, actually.
Is it also the roadmap to support kind of webhooks or whatever? So when you see that the transaction is happening, that is all from the stories and things?
Yeah, absolutely. We have a feature called monitoring, and you can give it a list of addresses. In fact, we gave all 2,000 Gitcoin addresses to a monitor, and it was just watching all 2,000 every 12 seconds whenever a donation came in. I can actually show you that real quick. I have a minute, I think. So if I do tokenomics, So we wrote this thing that was monitoring all the Gitcoin addresses, and just updating a database and then generating a lot of different pieces of data. This is about 2,000 addresses that TrueBlocks was monitoring on my laptop, generating data for this dashboard. And it's interesting because when you have, even with 2,000 addresses, there's a block every 12 seconds, and maybe 6 of them have a transaction. So it's a really light thing, so it doesn't take up a lot of resources. This worked for a while, and then we kind of stopped because it's a little bit of a pain in the ass. But yeah, no, you can do exactly that. Yeah, it's not full featured yet, that feature, but you're welcome to help fund us to do that.
And the last one, do you currently only have, let's put it another way, token balances, or could I also get information about all the contract interactions, etc.?
All the contract interactions. We call it articulation. So we get this ugly byte data. We can pull the API from some source, Etherscan, which is really the only source. And then with the API and the byte data, we decode that transaction. And we can give it back to you as what we call an articulated log or something, or an articulated trace. And it shows you in words what everything was. So it's very nice, actually. I think I answered exactly what you asked in a way that didn't maybe match up with your question, but yes.
Yes, you get.
We don't use webhooks or anything. We just kind of.
Okay, but you get the events out of the transaction, and then it gets decoded.
We decode it, and it comes back as English, and you can understand it really well, and you can pop it into your database and do whatever you want with it. And you could run it as a monitor, so you constantly have a fresh update of your state of your entire system, because it's not just logs, it's traces as well. So you get even more than just watching logs, which I think is something that you probably aren't getting elsewhere, most likely. Maybe. Or you wrote it yourself.
Sorry?
Or you wrote it yourself.
My personal one I wrote myself, but Tenderly as is web free.
Tenderly,
Where
yeah.
you get all
Yeah.
that stuff to you, and they
Yeah.
trigger the script on every block.
Yeah, we're going to start competing with Tenderly next year. Oh, I'm done. I'm sorry. Yeah, well, thank you so much for coming. I really appreciate it. Please communicate with me in Discord. I'm very helpful, and I'm looking for feedback, so thank you.